if I ever do. So, welcome. Pseudonyms Marshmallow and Squidward. And anyone who's watching online, I think I can even put a chat here, a message. Hello. This is Understanding Bitcoin Source number 4, and we're going to go over the technical details of block storage, which is a big debate in the Bitcoin, or there's no debate on block storage. There's a debate on how block storage is used with inscriptions. So I thought it was interesting to look how blocks are actually stored on disk. So, not clicked on this one. What is block storage? Before, I had a presentation on mining, and I just copied this slide over. What is a block? So a block, you kind of need to understand this to understand how blocks are stored. What is a block? A block's composed of a block header, so it has a version. If people don't know, blocks have versions just like transactions. You have the hash of the previous block, which is the whole point of the blockchain, to include some ID from the last block into the current block. And then you have a hash Merkle root, which is kind of like a commitment / hash to all the transactions that are included in a block. You have the end time, which is timestamp you could find these blocks. And then you have end bits, which is something that tells you the difficulty of the block. It's derived from this value. And end nonce is like the lottery number that you get to change. It's not the only lottery number that you get to change. You also get to change things like the timestamp, for example. It's a little bit flexible. You could change it to help you mine if you run out of numbers in the nonce, which can happen. And you have transactions, which I didn't really want to get into the details of, but just know that blocks have a collection of transactions to them. So what does a serialized block header look like? I think I'll come back to this. So first, let's go into what is block storage. So block storage refers to the mechanisms used by Bitcoin node to store, index, and retrieve blocks on persistent storage. Any questions? No? Okay. Okay, yeah, see the thumbs up. What is persistent storage? So if you've ever heard of RAM on your computer, it's ephemeral data that can be cleared after a program's execution. Typically data that's stored in memory, what programmers say, or in RAM. It's cleared, after you turn off your computer.
That's non-persistent, right?
Yeah, it doesn't persist between restarts of your computer. And yeah, ideally, everything in memory is cleared after your program runs. So it's, if it doesn't, then your program, something wrong. Disk storage is data that is persisted until deleted. So think things like the common hard drive in computers, or external hard drives, or SSDs now. And sometimes even after delete command is issued, you can actually have data that's still persistent. I don't know the standards for operating systems and right now, but in the past, when you would delete something, it's not actually cleared out of your hard disk. It would say, it's essentially you telling your operating system, this piece of data is free to be overwritten. And that's actually how data forensics, extracts data. So it's used to store data that must be restored between runs of a program, or even restarts of the computer. It's more persistent than RAM. Now, why should node runners care? You guys could pitch in if you guys have some other, reasons that node runners should care. So knowing the folder where data is stored and what each of the files are is essential for backing up the chain on an external hard drive. How are you supposed to back up the data if you don't know where it's stored? And a lot of people want to back up the data for various reasons. You could have your hard drive can easily get corrupted in a multitude of different scenarios. Sometimes if you have it on your laptop, you want to make sure that if your laptop is broken or if it's old and stops running for whatever reason, you just want to have this copy of the blockchain because it takes a long time to download over the network.
If you had like a full Bitcoin node, could you use the copy of the blockchain on that node to implement a separate node? Like, could you copy that data that blockchain and then, spin up another node on a different device?
Yes.
To save time?
Yes. Yeah. So, yeah, understand the trust trade-offs when locally syncing different block files from friends. So yeah, you can sync block files from friends.
But there are trade-offs.
Yeah. I mean, yeah, there's trust trade-offs, right? I'm like assuming that things are okay when you give me.
You can trust Squidward.
Yeah. I mean, but if they're really like invalid, then things won't be able to be built on it properly. So, but yeah, you can have a state that's transferred over, or block
I'm
files.
saying maybe that's one reason why node runners should care.
Yeah. And that's what I try to put for the second reason. There's also something called the block index, which I think I have a slide about, but it's another way to keep track of all the blocks you have downloaded within the files. So even when I copy blocks over, it doesn't mean I'm copying over the block index. And if I don't, I'd actually have to reindex things, which is very slow. And that's a process that I hate, which I'll go into later about a change that I was looking to make to Bitcoin. So why should developers care? As a developer, we care about our users and ourselves as users. So why should developers care? Well, how blocks are stored can impact block retrieval speeds. They can impact block storage speeds. And they can impact block indexing, which I made a small description for here. It's a computational process that makes retrieval faster, essentially. It's like table of contents almost. It's a way to look at certain pieces of data very easily. And also, knowing how blocks are stored is essential for changing consensus on block formats. So old data doesn't become unreadable or corrupted from a change. So anyone who wants to make a change to how blocks are stored should know how the existing mechanisms work. So that's why it's important to know how blocks are stored. So when does a node interact with block storage? Can you guys pitch in? Can you think of certain things that your node does where it might have to look at its hard disk? Anything that has to do with blocks?
Verifying a new block?
Yes.
It has to look at the old block for the hash, right?
Yeah. Processing new blocks. Exactly, yeah.
So if you're broadcasting a transaction, do you need to know about block storage?
As a user, you don't, but
you need a node to know like the transaction, like the UTXOs. Like there's data from an old transaction that you would need to compose a new transaction also, right?
But the UTXO set. And the UTXO set is a little bit different. That's there's something called the chain state, which I didn't quite cover in here, but yes, you have to know UTXO information. And yeah, so when you receive blocks, when you're listening on the network, when you do the initial block download, and I have a couple things here. Nodes listen for transactions and group them into blocks. So when you're listening to transactions, it collects the transactions and you make the blocks on them. When you listen for mine blocks and you store them on disk, and when you listen for block requests and retrieve them from disk, for example.
In that first line, is that when a node is acting as a miner? Listens for transactions and groups them into blocks, or do even non-mining?
Yeah, non-miners can do it also. I could send an RPC command to my node and it says get block template. And typically, if you're going to be solo mining or even be a mining pool operator, it relies on that functionality of being able to get the block template from your node. It's usually the custom implementations that differ from that model. But the easiest thing to do, is have your node run, and I'm sure most of these mining companies do it that way. In the places in the code where blocks are saved to disk, so there's something called accept block, which, as you can imagine, it's where a block is being accepted, and that can be called from processing a new block that you're hearing from the network. It can also happen if you're loading an external block file that you want included in the blockchain. And then you have load genesis block, which is actually exactly what it sounds like. When you're bootstrapping your node, it's the initial block download. The genesis block is actually, it's already made for you. So, but you have to, it does, even though it's in the code, it saves it to disk as as part of the first block file. So yeah, load genesis block, all of that one saves in terms of blocks is that genesis block. Meanwhile, when it's called from except block, it's all the new blocks. It stuffs in these block files. Relevant code snippets. I have source code that I have on the side. This was easy enough to look at, so I decided to just screenshot it. Maybe I could explain some of the stuff here. Because this is so small, I could do this. Not all, as you'll see in the next slide.
We're looking at C++ from the original code base?
Oh, no.
What is this?
This is all modern code base
This is
stuff.
modern.
Yeah, sorry. I did it.
Marco Fogg, I should have read that.
Yeah. In previous previous presentations, I went back and looked at the original implementation of Bitcoin for things. I didn't really include any of the original implementation in this presentation,
Okay.
but this is modern code.
Gotcha.
But yeah, this is a pretty small method. It belongs to this class called cChainState, and whenever you see this lock, it just means it's locking. The goal is to kind of lock this main thread. You have these things called mutexes, which help you manage access, because sometimes you have multiple things happening at once. Threads are like different workers almost. It's like different computational processes that could be happening they could be happening simultaneously, but they could also be happening like one after the other, but they context switch between them very fast. So when you are locking, with the mutex, you're making sure that a certain thread isn't gonna do something else as you're making this operation, essentially. Because if I'm saving a block in one thread, I may not want to be writing to the same block file in another thread. It just messes data up. Anyway, that's what the lock does. Sorry, hopefully that was a good enough explanation. Yeah, so you'll see these all over the code base, these locks, and I'll show you in the next slide too, where the code is a little bit longer. But yeah, and then you have a condition. If this is like the block manager, it's an m block man, m.mblockindex.count, and this is a very weird way, but they have comments that help us understand this. See, this line is checking whether we're already initialized. So it's just checking if this Genesis block can be found within the block index. But you actually do it in a weird way. You're like, get me the hash of the Genesis block, and then I'm going to pass it into this thing called count, which is a method defined on this block index, which is like almost a collection of these block indices. And basically, this will return true if it is non-zero. So it should only find one anyway. It's just a weird way of writing things in C++, the way it's convention used in the code. And then you return true. And there's a lot of nitpicks I can make about the code base that I don't like. For example, this is what we call an if statement. Pretty much you have like a condition within these parentheses, and if this expression in the parentheses is true, then the line right after it is followed. But you could also write curly braces, because when you do it this way, it's only the line after it happens when this if condition's made. If you have curly braces, that's everything within the curly braces happens if this condition's met. And I like using curly braces all the time, even if it's one line, because it builds consistency in the code. But that's just my preference.
So that's a syntax preference as far
Yeah.
as like if you're only returning one line, this is more common, but it works, curly brackets work, or curly braces works for one line as well, so why
Right.
would anybody?
Sometimes there's ambiguity.
Is it more readable like this?
I don't think so. I mean, I don't think it makes it shorter. Maybe to some it makes it more readable, but sometimes a common mistake I've seen in different code bases is sometimes people get confused and they'll put other things indented, and they'll think it's part of this if statement execution. It's like, no, only this line will get run. Even if you have things indented below this, they won't get run because you didn't use the curly brace syntax. So again, kind of away from the point, but it's nice to learn a little bit about programming. You have this thing called try, which means that you try to do.
The then, if this.
Oh no,
if it's true, return true.
right? Yeah, this is the if, this is the then, and this is the one-line syntax. The try is completely
It's a new way
separate
to
structure. Yeah, This try is saying, let's try anything in here. And then if something like doesn't work, then we're going to catch the error. And then we're going to do whatever's in here. So what are we going to try and do? We're going to try and get the genesis block, which is saved in this thing called mparams. Params is something that like you initialize your node with. There's some default values. If you wanted to fork, your node for whatever reason, you could change certain things in the params. But yeah, they have like a lot of hard-coded like methods and like or hard-coded data that's returned from methods and default values. So the genesis block is one of those things. If you call genesis block on the parameters you start with your node with, and again, these are typically going to be like default stuff, then you'll get this genesis block as this object called a C block. And then, let's see, how much do I'll just go over this part. This mblockman stands for block manager. You're saying, hey, I want to save this block to my disk. And then you pass it this genesis block, right? This genesis block is set. Code is right to left. So you typically have like an expression that's saved in a variable on the left whenever you see this equal sign. So the genesis block was stored in this thing called block. Then we call the block manager save to disk, which saves the block. You add like, I think this is the position that you want to write at. I'll have to look at the definition again of this method. This is the chain that you're using. So the params you're using, and then you put a null pointer, which I forget. So like it should, save to the block to disk, okay, and actually return something that like helps you locate where things were saved to. If it's null, it means it didn't write correctly. So I kind of minimize this expression. So you see the 3 dots here. And then you add it to the block index. Remember I said like the index is almost like a table of contents type of thing. It's like a way they could easily reference information about the blocks.
Right. mblockman is a directory?
Huh? Or no, the block. Oh, this is the block manager. This is like
Wait, it's a file or what is it?
It's like a module, let's say, of certain pieces of functionality. So I'm trying to like think. Squidward, has a lot of time near the water, right? And he likes fixing boats, right? So I imagine you have different containers for different tools, right?
Boxes, yeah.
Yeah. So mblockman or block manager is like a container for a whole bunch of tools you could use, or a bunch of utility like functions you could do computationally. So that's why like we just kind of put it in block manager, but it's almost like a container. But that's how you segment your code, just so like you could have a good separation between like files and try and put relevant things together in the same toolbox.
So what is the relationship between like save block to disk and mblockman, or mblock index and mblockman, or add to block index and mblockman?
Yeah, so there's a file, and in this file there's something called like a class. That's again kind of like a toolbox. It's like the quickest non-technical explanation I could do. And save block to disk is defined in the file with the definition of mblockman. It's also saved in the file with the definition of add to block index. So that's how they're related. Add to block index is related to mblockman because it's defined within what we call the class, within the specific file. Actually in C++ it's a little bit weird. You define you declare what we call the function somewhere, and you could define it somewhere else. So it's actually declared in one file, but it's defined. It could be defined in a different file. I don't want to complicate things, but it's like a toolbox. So this add to block index, we go and we add this block. Again, there's this like table of contents. Received block transactions, something else we call. Again, this is just loading the genesis block. And then if there's an error somehow by saving this block to disk, then you return an error, and you would see this failed to write genesis block coming straight from the
string.
Yeah, it's a string that would get shown if your node ran into this, but really shown on the command line. I don't know if you guys have run a node on the command line, or you could also use the UI. This is the other place where save block to disk is used. The save block to disk. It's kind of too long, so I didn't want to go through all of it, but I can kind of skim through it. Let's see, anything interesting here? Except block header, it does some validations on the block. You do this thing called like check block index. I don't need to really explain too much.
This is like the node determining whether a new block is valid or not?
Yeah, that's like part of it. It does some of the validation here. This is actually, I'm pretty sure this method is defined in a file called validation.cpp. And we could actually find out if I want to go and see this accept block. I could actually search for it. Accept block. And yep, it's in validation.cpp. But yeah, there's some validation that happens here. See, we like if we don't have an accepted header for something and we return false, you sync block headers when you first start your node. It's part of like what we call IBD or initial block download. It does a header sync. So you actually should have headers for certain things. You can prune files, so that means like you could delete old files. Yeah, I mean, if you delete old block files, yeah, you're essentially deleting inscriptions.
For your node.
For your node, yes. Yeah, someone somewhere, if you want to keep the whole history of the blockchain, you can save it all. But they can be pruned. And I think, did you have a...
Well, so like pruning, obviously a prune node cannot be used to help someone else do an initial block download, right? Because they don't have all of the data.
Correct. But they can serve...
But they have enough of the data to like accept or determine whether new blocks are valid or not.
Yes. And they also have enough data to sync other people who are close to what we call the chain tip, or like the newest block. And there's
just the tip.
Yeah. And there's a config value you could set to say how many blocks like you want to like keep or whatever. And I don't think it's here. I think I have it in one of the slides, hopefully. If not, I can look through the code for it. But yeah, you could set in your bitcoin.conf file, which is the place you put your configuration for your node, and you could actually specify how much you want to prune. And part of one of the changes I want to make, I was talking to, what was it, Bubbles?
Marshmallow.
Oh, Marshmallow. Good. Thank you for remembering. Yeah, I was talking to Marshmallow earlier, and someone else, Cinnamon, who was here before, about change I want to make to Bitcoin, which is right now when you prune blocks, they're deleted. You have it in your table of contents though. You have like shove the information in the block index, but you delete the block files. And I'm thinking, I have a couple different changes I want to make, but one of them is I wonder if there's a way where I could just offload these block files to a different hard drive and make my node aware whenever I plug it in, so that I can always like pick up and start serving blocks whenever I give it available or make it available.
I like that.
Yeah, that way it's like, you could still serve early blocks, but you could do it on demand. If I have it on my laptop, for example, maybe I want a prune node, but if I'm at home, I don't mind plugging something in because I'm on a desk, I'm on my lap or something.
Yeah, and then you could update that larger file to like make it up to date, or as up to date as you wanted it.
Right, yeah, and I could prune more.
But your
Yeah,
laptop
exactly.
would still be pruned.
Yeah, so something like that I think would be cool. It takes longer to pull blocks from an external hard drive and serve it to people, so that's like not great quality of it. But if it's old blocks anyway, how many new people are going to be syncing their node on a day-to-day basis? So let's see, anything more interesting here? Yeah, this has something to do, has more or same work. This is pretty interesting. You do certain checks to see if a certain block has more work than what you already are currently aware of. Anything else interesting here? You have certain...
No, it's behind that J.
Huh? Oh, what, this too long to read now?
Back door.
Yes.
Yeah, it's too long to read now. Save block to disk, yeah. After all this code, this is actually a pretty long piece of code, so that's why I just said too long to read. And yeah, at the end you kind of save block to disk, and then you do this receive block transactions, where you go and process the transactions that are in the block, and you see you get the block and other information. And if it doesn't work, an error. Flush state to disk is like actually saving it to file. The way operating systems work is sometimes blocks don't get saved like you tell it to save it to your hard disk, but it doesn't actually get saved.
Until you flush it.
Yeah, until you flush it, essentially.
First, you gotta flush it to save it.
Yeah. Feel free
Another
to,
back there?
yeah.
That's mine, sir.
I mean, I can move and you could get by.
Or
There's-
pen rotates.
We're good.
Okay.
Here, you can come this
Well, there's,
side.
you know, it's just, oh yeah, you could also go on this side. That side's completely open.
The pen's pretty trapped. I mean,
Yeah.
Squidward.
Yeah. Already doxed them. That's okay. Do you,
There's visual stuff. as
yeah,
well.
yeah.
That makes sense.
Yeah, well, we could have more discussion on the last slide or have like question slide. Do you have a pseudonym you want to assume or, you know, I call.
Super art. I don't know.
Okay, that's not very. So like I've given him,
Marshmallow.
yeah, Marshmallow, and I've given him Squidward. You can, I mean, you can have Super Art. That's fine. Yeah,
It's fun.
yeah. You know, they're just kind of ridiculous names. You don't have to choose one. I just do it for fun. I mean, for Marshmallow, you know, I know he likes a pseudonym, but Squidward doesn't really care. I just thought it'd be funny. If you want to be SpongeBob, yeah, that works too. Yeah, I was going over some of the code, but you know, I'll just skip to the next part since I think I'd get a little too boring. If I stay too long on it.
That was too long to read that last
Huh? Oh yeah, you can have it here. Yeah, yeah, just to like, because sometimes you know I'm like, oh, yeah, why don't I read this whole thing? But I'm like, no, I should probably remind myself that I don't want to read this. So where do the files get stored? The block files get stored. And I have this thing, you know, back in the code, you know, I have this save. I know it's kind of hard, like, to put it all together, but, you know, I said these two methods, they call a method called save block to disk, which is accept block when it receives new blocks and load Genesis block when it just starts up. And in save block to disk, it kind of goes to the sequence of method calls. And, you know, it's kind of hard to get all in your mind conceptually, but it's a nice, you know, flow chart to try to make. And then, yeah, so where blocks are stored, you can actually find where the blocks are stored in the code in this method. It's stored in something called the blocks directory. So all Bitcoin nodes, they have a data directory. And actually, let me see if I could just show you an example, because I have a development Bitcoin node on regtest somewhere here. Yeah, this would be good to show. It's too small. Yep, I know it's too small. UI tweaks. Yep, I was running stuff on my hard drive. It's clear. So this is a Bitcoin node on regtest. You know, usually if you're on a Unix machine, you could find Bitcoin. Where is this? Oh, so my home directory? Where is this? Okay, I guess it's in my home directory. Wait. Yeah, it's in my home directory. I have this directory called Bitcoin. It's for all Unix-based systems. It kind of should be the same. And in here, I should have the different chains. But you know, here I just have my regtest chain. And then, so this would be considered my data directory. It has information about my wallets. If you really wanted to back up your node, you know, this is the best way to do it. Find the .bitcoin folder if you're running Linux and just copy it over. But yeah, your wallet's obviously very important. If you do hold money on your Bitcoin.
So wallets,
node.
it's going to be a bunch of key pairs.
Uh,
Or are they get what's going to be?
Yeah, all the information needed, you know, regarding
Yeah.
your wallet. So
Okay.
yeah, so you know, whatever information you can make, descriptors and whatever
Descriptors.
else. Yeah, keys, everything. But what I'm interested in is regtest. But this whole thing is your data directory in .bitcoin. Usually, you know, you have some mainnet type folder here. And bitcoin.conf is where you have all the configuration. I could run this thing called cat, and I can look through the bitcoin.conf, and you could see that I have my chain configured to regtest. Have it listening, you know, for other peers.
Right. Test me.
It's like if you want a node where you could just make blocks on demand, it stands for regression testing.
Like a test net almost?
Yeah, but like one that's personal to you. Like typically it's a solo developer. We don't share like a reg test.
I see.
Yeah, we could share something like a Signet, but yeah, reg test is kind of typically used in development environments when you want to be able to like make blocks easily. I could technically make a network with you if you run your own and gave me information in terms of like the peer information, but yeah, typically used for development. But yeah, it stood for regression testing. First, we call it reg test. Some people like using a JSON reg test or something. I use reg test. Yeah, I have it set to listen. I have some default values for my node to make RPC calls with it. So that's my configuration. What I wanted to show you was if I go into the chain that I desire and I look at it, you can see this blocks file. And going back to, not this, going back to, not this either. Where's my presentation? Okay, this is it. Going back to my presentation, see, wait, is it? Oh, I'm wrong. Okay, maybe I didn't give enough context here. But part of this, basically, the directory that's used is this blocks directory. And if I look in the blocks directory, you actually see these. Ignore this. This is just like a backup I made, and this as well. But if you look back at the presentation, you can see there's something.dat. And this is, I guess, the closest link I could show you to like the code and what's actually saved. But yeah, this is what's saved in my block, BLK 000. And they're actually like numbered sequentially. I have my hard drive with my node synced to earlier this year, I don't know, maybe beginning of March or end of February. That was going to show real block data, but I don't really need to get it. And this A is also something I added.
Basically like a text file, or?
Yeah, we could. Well, it's stores binary data, so like I wonder how it looks here.
Everything's a text file.
Yeah, I mean you could try and interpret the bytes as text, but it's not like
Sure.
ASCII2 text, which means like it's it's. But yeah, these are bytes, so you kind of get randomness whenever you try and output. No, okay. But yeah, that's how that looks. And again, these twos are just copies I made for testing stuff. But usually you see just .dat. The next one's going to be 1, 2. It's exactly what you'd expect. It is regular numbering. I don't know if I go over this too much in my presentation, but these are like what they call undo files. Yeah, sometimes you'll get a block that is like uses a different history than what you're currently treating as the main chain. So imagine if you have like network segmentation, right? And I'm like here in the US and SuperArt is over, or SpongeBob, whichever one, is over in China. And we're both mining our own chain, and all of a sudden he goes and he publishes information about his chain to the rest of the people here in the US. If his chain has more work, then I will eventually go and adopt your chain as my main chain. And the way that like I do that is I kind of find where we branch off, and then I use these things called undo files to help restore the UTXO set at that point. So that's what these things are. They have the same numbering scheme as these blocks. Again, I don't know how much I go over it in these slides. You also have indexes, and I was talking about indexes before, but which are, it's almost like this has a TX index, so guess there might not be yeah, additional information. I want to show you my full blockchain, but I don't know if it's that necessary. But yeah, this is, if you ever ran a Bitcoin node, you have this on your computer. Whether you use the UI or you use it through the command line, you'd always find this information. So make sure people don't try and steal your wallets or something. So yeah, mdir is the value of the data directory, or the argument blockstr defined in bitcoin.conf. So you actually like define where you want your blocks to be stored if you want it to be stored separately. So there's a default data directory, and this is what I use here, which is like, how do I get this thing off? This stupid, wasn't deciding. Anyway, it doesn't matter. It's just kind of annoying here. Hide. Nope, that. Let me see if I could just, okay. Yeah, so this is the data. This is the data directory right here. And if I wanted my blocks to be saved outside the default data directory, or if I even wanted my data directory to be different, I could set that through that bitcoin.conf file that I had above. Of course, everything is out of order. Yeah, the pos.n file here is the file number that should be written to. The pos is calculated in load Genesis block and accept block. So actually, an accept block, you figure out which file you should write to. And sometimes that's a new file. If the last block file you're writing to is filled up or is going to be past a certain maximum, it just makes a new file.
Is that for like a position of like where? Like what is the pos?
Yeah, like so. There's it stands for like position.
Okay.
N
So
file
file.
stands for
Which file?
but I think the other one is like n pos, and that shows where you should write to in the file.
Okay.
So
Within the file.
yeah, and this is calculated in accept block and load Genesis block, and pretty much part of how that's calculated is looking through other in-memory information that you keep of your on-disk blocks. How do the blocks get stored within the files? So there's something called serialization, and I should have had the other slide, after this one. I had the early slide, and I'll go back to it. But Microsoft had a good definition. It defines serialization as the process of converting the state of an object into a form that can be persisted or transported. So there is, I had this template for a block. I said, this is all the information that's stored in a block, but this is not really how it's like, I don't know, it leaves some questions about how it's written to a file or how it's transmitted to other people. And it's pretty much kind of like this, it's like, but it writes it to the bytes. It's not human readable. It's not in ASCII2 text. It's straight bytes.
So when there's all this conversation about like we can decentralize miners with allowing them to submit their own block templates rather than the pool level.
Yeah.
If you go back to the, are we talking about the same thing as far as like, what is really something like, how much room do you have in your own template to actually be like, I don't understand, I guess.
Yeah. So
what I would change on my template. I've always just relied on a pool, so like I don't know.
yeah. So this structure is
Yeah.
typically not what they're talking about.
Okay,
The template is this part of the transactions.
I see. Right. So that it's yeah.
Yeah. They're like, let's include different transactions.
So that is all that's going to be pretty much
yeah, it's the same.
the same. And
Yeah.
then where the subjectivity comes in on how you want the templates is the transaction.
Yeah.
of the block.
Well, yeah. With respect to mining pool operators
Okay.
and the hashers that join that pool.
Gotcha.
Yeah.
Thanks.
But yeah, I saw this is kind of how it's serialized blocks. I went over this in a previous presentation, and I decided to kind of touch on it again. These, this is like hex when you use two numbers. I just kind of put placeholders here of 0 just to show you like how long each part is. So this is the end version. The red part shows what the green part was. This is like the hash previous block. It's pretty long. Hash Merkle root is pretty long. As you can see, these hashes are pretty long. The time, it's not very small, but a lot smaller compared to the hash. And I've mentioned this before, but there's actually a date where you'd have to hard fork, or else this time the data in here isn't sufficient for the future time.
How far in the future is that?
I forget. It's pretty far. We'll probably be dead.
Like thousands of years?
I don't know. I can't remember.
Interesting, because that'll have to be like a non-contentious art form.
It should be. Yeah, you never say anything's going to be non-contentious.
So they're gonna probably like try and stick in other changes at that time.
Yeah.
Of course.
Because this is gonna be
Taproot
in the
V2,
future.
yeah.
What is it? Pork barrel?
Pork barrel spending or earmark spending.
Yeah, it's Taproot V2. Hopefully it doesn't take that long. Let's see, going back to my serialization. Yeah, and I had an example here. Serialization is, if I want to store the number 2 in a file, I could fill the file with the byte. Like I could store it as text like this, or I could store it as the human readable character 2. The byte format won't be displayed nicely if like I actually wrote it as bytes, because what I'm displaying here isn't like, it's not really stored in the computer this way. But yeah, so it won't be displayed nicely, but the character 2 will. So there's like different ways you could store things, right? Even if I stored it in human readable text, I could use it this way or 2. It depends who's reading it, right, and how they prefer to read in the information. Block positioning. So there's something called mlast block file. It's like a variable, so a named piece of data in the code, and it's a value stored in the level DB file. So you store certain information in this thing called level DB, which is made by a very famous Google engineer called Jeff Dean. It's made maybe someone else it also works on it, I forget, but he's a notable person because he just released, or he was doing huge contributions, if not leading the project for Gemini, which is the latest model coming out. So a fun fact. So yeah, level DB is used within Bitcoin to store certain pieces of information, like this mlast block file, which is supposed to be the last block file that you have written to. It's used to iterate all files from 0 to the last block file and store certain details in the memory within the variable mblock file info. So this is almost like a different kind of like index. Sometimes you want to like a cursory glance at all the information stored in your files. So what you do is you kind of like load them all up, load some of the information up in something called mblock info. So you have it in RAM, and you could easily look at certain things. You don't want the whole block. You don't want like every block and every transaction loaded in RAM at one time. But so like you go and you extract certain pieces of information, you put it in mblock file info, and like you just have that as a handy reference to do stuff with, without having to do a read to disk every single time. Because I don't need to know all the transactions that are in every single block. And yeah, we have this thing called find block position. So remember I was talking about before, like when you receive a block, you want to find out which file to write to and where in that file to write to. So this is the thing that does that. It's called find block position.
Is that a method? What is?
Yeah. Oh yeah, so I did this to show people what file it's from. So
Right.
It's from a file called blockstorage.cpp. And then it's like defined in this class called block manager.
The block man.
Yeah. Block man, yeah, is what we call an instance of block manager. So
Okay.
really classes are almost like blueprints, and you like make the blueprint into what we call instances. And the instance of that block manager that we use in a lot of Bitcoin is that, M block man that you were talking about. So yeah, find block position is defined within that. And then this uses the information to see if the last file in mblock file info has enough space for another block. Because again, you always want to see if there's enough space. And then if it's not, you allocate space for a new block in memory if it doesn't, which is like that almost like a summary that's sort of mblock file info. You add one there first. And then you initialize a block position with the information of the new file you want to write to, or the old file that still has space, and which byte in the file to start writing from. Some interesting ways of like how things are stored. See this last block file is in level DB, which is completely different from how like blocks are stored. Blocks are stored kind of like naively because most of the time you don't need to do much to look through the transactions. And I was trying to see if I could see there's something called chain state here, which has UTXO information. I'm trying to remember where. I think it's stored in levels DB. Let me look in write-test 2 to see what I have up. But there's a certain place you store things in levels.bd. I mean level DB that I can't remember right now. One of these. But yes, see what's it. Anyway, I'll skip. It might be in this index file, but I can't remember. So next part, block positioning. So putting it all together. Except block finds which file to write in, so it encodes the information in block position. Block position is used to find the file, so it can be written to in write block to disk. And then write block to disk serializes the accepted block, and then it writes it to the file. So how big is a block file? A block file has a certain max size, which I don't think I included in the presentation, which I'll probably find the code for you. It's around like 130 something megabytes, I think. But yeah, when you allocate a file at first, you kind of allocate this starting number of bytes. So here, this is like, again, my write test node, and I haven't made enough information for it to go past the default number. I don't think I have. Yeah, So whenever it makes like this new block file, it allocates some space for it.
How is that specific part like determined?
I have no idea. Or they have a constant in the code, so they define it there. How they chose it, I'm not
Like,
quite
is
sure.
there like a specific reason for it, or is it like a random number that's high enough?
There could be a specific reason for it. If there is, I'm not really sure what the logic.
And that's 16 megabytes.
Here, block file chunk size. We'd actually look. They have the sizes written. Yeah, it's like weird because the way that you might want to count bytes
Is
is like,
different, right?
yeah.
You have to change it to bits and like.
Right. Well, yeah. Some people say like 1024 it should be like a kilobyte, and some people are like, oh, it's 1,000. So that's why like you have this disconnect between the developer community and the marketing departments of these computer companies. So that's why I'm like, I wonder what they say it is. Block file chunk size, block file chunk, and sometimes they have comments that like say why they pick. Yeah, about 16 kilobytes is what they're going for, but some people would say, oh, they should be like zeroed out or something. But again, we count sizes differently than the marketing people. But yeah, if you look where this is defined, pre-allocation size. These aren't actual question marks; they're just like placeholders because 0001. But yeah, you have nice little comments. Pre-allocation chunk size.
Why are the question marks?
This is just saying for blk.dat files. This is just like placeholder for like 0000.
It says 16 million bytes.
Yeah, so 16 megabytes.
I've never seen it written like that. Billion bytes, like.
MIB, you're saying?
Yeah, I've never seen it written.
Oh no, this is like megabytes. I think they were going for here.
I mean, it's
But why not
million bytes.
Huh?
MI is million, and then B is bytes, like that.
Yeah, I don't know why they decided.
MB would
Yeah,
be megabytes, which is a million.
yeah. So the yeah.
But the
He's from a different
because you were
place.
talking about
He's
like.
not from
Yeah, he's not from here. So yeah, these are the rough files, the undo files. You have their chunk sizes. You have the max block file size. I said about 130 megabytes, and but it's actually like 128. But again, we count differently. I think it's actually closer to like 130 something if you look at the actual sizes of things. In fact, I wonder if I could go. So I had my hard drive plugged in earlier. I wonder what information I was looking at there, and if I could get more. What was I doing here? Okay, I already lost it. Doesn't matter. But yeah, so that's the max size that they try and have for a block file. Here, 128 megabytes. So you kind of have like nice.
A megabyte is 1,000 square bytes.
Square bytes. What?
Yeah. And then a mebibyte is 1,024 square bytes.
Uh-huh.
Chosen by the International Electrotechnical
Oh,
Commission
okay.
in
So there's some
1999.
standard, yeah. So I guess they forked from megabytes and they said we have to use this to use our sizing metrics. Okay, well that makes sense. Yeah, to differentiate between the marketing sizes like I was talking about and developer sizes. Yeah, so that's how big a block size is. And I was talking about serialization, described in previous slides. So you can keep adding block data essentially until it doesn't exceed this threshold of 128. And when it does, you allocate a new file and you kind of make a pre-allocation for it of 16 MIB. Forks and upgrades. So here I'm talking about like consensus valid forks. Again, going back to the example of me being in the US and SpongeBob being in China, both of us make our own chain and we come and talk together. We have to come to a resolution on whose chain we should follow. And if SuperArt has more work in his chain than mine, then I'm going to take his chain. If I have more work, then you're going to take mine. Because we're both ideally running the same rules for consensus. So interestingly enough, SegWit, you don't really need any changes to how blocks are really stored here. Because of the way blocks are serialized, you just kind of serialize the whole transaction. And in the class of the transaction, you specify how to serialize in there, but there's not really like any block enforcement that needs to happen. You change it on a transaction level, like when things are in memory. This is the new way it should be serialized as part of a block. is what you do. So, and you actually, so yeah, whenever a C auto file is open, which is another one of these objects or tool sets that help you manipulate files, it takes in the end version and writes to the file before the data. So when you write a block to the disk, you also try and specify which certain things like your client version, but of course the end version of your block is included in here. So when you read blocks, if you look at certain things in the block version, or even how the version that it uses when it serializes things, the client version or whatever, you could start making decisions about whether this block should have SegWit transactions or not, essentially. So this is common in many software protocols like TCP/IP. What's common is you have a version field somewhere. So if things that are, you can't really go back on, you typically want a version field up front. So TCP/IP, they have this with their IP. There's IPv4 they call it, v6, but IP packets have a versioning to them. But it's built into it, so to disregard things that you can't understand. So what happens when there's a consensus valid fork? Sometimes miners choose to mine different blocks for the same block height, and like I was talking about again, this can happen due to network segmentation. You could also have fee sniping miners. I mine a block, and Squidward is wow, that block has a lot of fees to it. I want to go and steal it and mine it for myself. And he does that, and he mines the next block faster than I can. That can happen. Yeah, or greedy mining. Squidward knows he has a lot more hash rate than I do. So he actually just makes his own chain, never listens to me, and then he makes it waste all this effort. And then after I'm done wasting all my effort, trying to be inclusive,
to the wild.
Yeah, you release your chain, and then it messes with my stuff. All my work was done.
Disregard.
Yeah, but Squidward has to be very confident to be building his chain in private to know that he'd overtake me. And even when he does that, I was going to include a tweet in these slides about this command called invalidate block, but there is a way for me to say I want to invalidate the chain that I just got from you, and I'm just going to go with what I had before because I don't Squidward is just playing games.
To counteract greedy mining, you would use that?
I'd invalidate a block, and I don't know if you've seen, but I feel like you're pretty caught up in the Twitter drama. But Reindahl, he released a script about inscriptions. He's why don't you just invalidate the blocks that have inscriptions?
No, you don't I saw it being deemed as malware rather than a solution. It seemed like
What was the script?
It is malware
No.
because it's a consensus valid fork. So
Yeah.
it's
Well,
But it achieves the goal of not allowing
inscriptions.
non-monetary transactions in blocks.
it doesn't
Which is-
quite
If that's even what it does.
Yeah, but no one. If I have block A, B, and C, and block B has inscriptions in it, and then I invalidate block B,
C is gonna be upset because
right, exactly.
It fucks up C.
Right, so I need B2 now, all right? And it's no one's gonna be making B2 because I'm because most miners, they want to make money. They're going off C. They're gonna keep B. So if I'm disregarding B, no one's B. What, you want me to start building off B2? And only people who invalidate B can follow B2 because otherwise they'd take B, C, D, and what all the miners are on.
Mm-hmm.
So it'll stop you from syncing. What actually happens is you kind of store it in you take the block header and you're oh, this is a bad block header, and you store it in this data structure in memory. But if you restart your node, it'll sync again to the latest. So there's a somewhat easy path to recovery. It's just restart your node, but it's very annoying to recover in this way because the processes that happen to go and compensate for this invalidated inscription block. Actually, I wanted to talk about it, and I was going to include the tweet, but I was I could just talk about it here.
You can do it.
Yeah. So. Yeah, it was fine. We already know, the controversy. You've seen the tweets.
But we have another viewer on Twitch that might not.
No. Yeah, I'm not logging on Twitter on here as well. So, questions. Yeah. So this was pretty much the end of what I had. We can look at some of the code some more, but I wanted to see if any of you guys had any specific questions about what's happening.
Well, this is not really related to most of what you talked about,
That's
but what you talked about made me think of it. what if aliens,
Uh huh.
what if aliens invented Bitcoin?
Okay.
And then their whole plan was, okay, they release Bitcoin into the wild, and we're all like, oh yeah, we start mining, but like secretly they have this crazy amount of hash power that like is just way beyond anything we could do.
Uh huh.
So then they let's say in the future the world has adopted Bitcoin, and then they come along, they're like, oh yeah, by the way, how about this blockchain? And it's like a consensus valid blockchain,
Yeah.
and it's got way more work than us, but it
Uh-huh.
like invalidates like pretty much all of our Bitcoin history.
Yeah. So we'd have to start like, yeah, we could either take their,
Work off of that.
huh?
That
Yeah, but
would be
Classic?
war.
but they'd overwrite.
It's our war.
Yeah, they'd overwrite all of our stuff though. Like, let's say they started from Genesis block, right? They use the same Genesis,
Well,
but had
we can, work to a different algorithm.
There's no escape.
Yeah,
There's
but
no
that'd be a very
standard
fast,
basic.
very fast hardware. And how about if they try? How about if they like?
Alien resistant miners.
Yeah. How have they built that in? Like how would they like have a whole bunch of different? They have the alien Litecoin or something.
Yeah,
so
we need alien resistant consensus mechanism.
yeah,
So this is my new Bitcoin sci-fi idea.
Yeah,
They
but we
come in
can-
and validate our.
right, yeah, we could invalidate their blocks, and we could like as our running node is invalidating that chain, we could go and make updates to the code. But it's like also like I was gonna say, do we wanna update or like change? And I guess we do because like we find our history valuable, so we'd have to find a way
Yeah,
for
but do you find your life valuable? Because the
Uh-huh.
aliens are going to give you this decision.
Yeah.
So either you go with the large,
Yeah,
the most
yes.
work proof of work blockchain, or you die.
Yeah, I mean that's that's a more existential threat than just money. Then,
Money was their plan for cooperation.
I also had this flowchart that I was gonna go over.
Well, the time is now.
Yeah, so I try to map out all the different like methods and stuff that
What did you make this flowchart on?
something called Mermaid.js, a very popular tool with some programmers, I guess. Yep, you use the live editor and you can make flowcharts in it. As you can see, it's a very big flowchart, and this is like me just trying to load things in. The chain state kind of includes things like the UTXO set, but also includes things like the block index, which again is like table of contents for things. You have load block index, so you kind of see the path things happen. But it's like very hard sometimes because from load block index DB, you call load block index, but you also call open block file. It's like, which one do you call first? And I'm not able to put that into a flowchart very easily. Some people are like, oh, you should put load index DB into load block index, and then if open block file happens afterwards, then put a line back here and then go there. But then the whole thing gets more complex.
That's for sure. I mean, maybe you could number them or letter them or something. Like you could have 1 and
Yeah.
from there 1 and 2.
Yeah, but then it's like hard to place the numbers, and you get really confused. It's like, oh, does this number go with this line? Like, it's very like I don't know. I actually gave this to ChatGPT, and it pretty much timed out. It was like, oh, we can't do this.
mean-
So I was like, all right, let me do it myself. I tried to give it like I didn't give it as much as I marked out here, but it just would not take what I gave it. But yeah, it's nice seeing this app init main. Can you imagine what this does? It's like where you start your Bitcoin node.
App initial main.
Yeah, it's initializing. Yeah. And then you load the chain state, and again this loads this Genesis block.
We looked at the whole method for loading the Genesis block, right? That was
Yeah.
So that included the validation chain state load Genesis block. That was the code for that box. Would you say is that?
Yeah, load Genesis block can also be called from this thing like thread import. I try
As
to
far
put,
as representing, that block is kind of representing that little.
that first code snippet that I had. Yeah,
Short
this
one.
block. Yeah. Although I did minimize part of it, the
Yeah.
ellipses,
Mhm.
but that was a small part because I wanted it to fit nicely.
Right.
But you pretty much saw like 90% of it, the small portion. So load Genesis block, and you can see where all this goes. For example, you want to add it to the block index, and you want to save the block to disk. So yeah, it's like cool saying, oh yeah, we start up, we load the chain state, you clean up these undo files, you go and you load your block index again, which this is from level DB, and I think it's stored in the index folder within blocks. and you load up the block index, the table of contents. You also do the load Genesis block. Then you have like a whole bunch of other stuff happening. See, like I kind of just started from process new block headers, but there's a whole chain that goes from app-init main to process block headers that I didn't want to put in. It'd make it too big, and it doesn't like it like spaces things out okay, but it doesn't do it all that great. So yeah, so process new block headers, you can see, oh, it goes to accept block header, then it goes to add block index, and all these lines. You know, I was going crazy mapping all this out. There's also another process new block, you know, here, chain state manager, and this calls accept block. You can also include, this is the other one I was talking about, the code that I showed earlier. Again, when you accept block, you eventually like flush the state to disk, and this does a whole bunch of stuff. You know, there's like pruning involved, and yeah, files. You find files to prune. Oh, and that's what I didn't like include that I wanted to include. There's like pruning. You could set how much you want to prune. I did mention that a little bit. So you prune one block file, things like that. Let me see if I can see some of the pruning code, because I think that might be kind of interesting for these last 10 minutes or so. But if you look, yeah, and all this in blockstorage.cpp. So if any of you guys want to go and make a change, you know, you have this to use. Let's see, let's look at some pruning stuff. All right, so already here, fine, no. Let me, oh, no. Yeah, it's always something. Yeah. No, not again. And then I want to, prune one block file. You see it here. It's not what I'm looking for. Removing unusable block and rev cleanup. Now this is the cleaning up the undo files. Again, when you want to resolve certain consensus forks. Find files to prune manual. This is helpful because there is a way for you to set how many you want to prune. So I don't know if you guys are running Node right now, but if you guys want to prune nodes in the future, actually no, this one isn't even used. Which is another thing about some of this stuff. There's a lot of, I did find some things that have been defined but don't seem to have uses.
Were they previously used?
Actually,
like
no.
Bobcat or something like that used to exist?
No.
You know, like, I'm just saying.
I don't think this is the one though. I think I reopened it incorrectly, and that's why. Yeah, because I see Node here, and this is not what I wanted. This kind of like messed everything up. Open recent, Bitcoin. Oh my goodness. Yeah, this is only the node folder, so it actually should show where the rest of the stuff is. One second, let me bring this over here, and I'll reload the whole thing. Yeah, you know, coding tools are annoying sometimes. Okay, this should be the whole thing. Yeah. Now let's look for it. Good. This is found. Validation.cpp. And manual prune height. Let's look at where this is defined. Flush state to disk. Yeah, as you can see, James O'Byrne did a lot of work to this. You know, I have a little extension that shows what, who did what, when.
Yeah.
Let's see, flush state to disk. Block storage. No, I think it's somewhere here. Yeah, it can kind of be a pain going through all of these. See, I'm like looking to see where I want. Yeah, and this is why it takes so long to make changes to Bitcoin, because you know, it takes a while to understand where everything is. Yeah, but Prem is gonna make it change. You know, Marshall already used his name, so. And manual. Yeah, I wanted to show where like you could set the prune, but now I'm not even sure where this thing is. So yeah, even I get lost in this. I think that's the moral of the story. You know, sometimes you can get lost in where things are. Connect tip, flush state to disk, manual prune height, because there should be somewhere that passes in this. Oh, but there's also like an automatic prune. I think that might be easier to look at. Find files to prune. This is probably better. Get prune target. Yes, found it. Prune target. This is in the block options in somewhere. So you can even see things like this. Here we go. You can dash prune. Block pruning. Get the amount of disk space in MIB, to allocate.
Heavy bytes.
Yeah, for block and undo files. So you can actually say how much you want to allocate. So if I want 100, not megabytes, but something like megabytes, I can specify that.
And it has to, yeah, can't have a negative value, or else you get that error.
Yeah. Pruning cannot be configured with a negative value. So yeah, this is nice because I could say how much I want to store on my laptop. Yeah. Again, I was talking to SquidPrem about
Framework.
a cool change might be to say, hey, I want to prune 100 megabytes, but I want it to be on my hard drive, and I want it whenever I connect it to my computer, my node, but I want to be able to disconnect it also. That might be useful. So when you prune right now, it just deletes the files. You keep like a block index information pointing to that, so you don't lose track of all of it. But yeah, it's pretty much deleted. So that kind of sucks. And yeah, anything else you guys might have questions about?
When is the next Understanding Bitcoin source?
It's every other Thursday, so 2
Do
weeks.
you already have a topic?
No, not really.
So you're open to suggestions?
Yeah.
I do enjoy, trying to dive into topical, current, kind of like a little understand it so you have a little bit more of the big picture on the thing. I think so I don't have anything jumping, but I like this one. This is the best ones for me.
Yeah,
Out of the
okay,
four
cool.
that I've attended.
Yeah, I mean, it had the least amount of code covered, so.
Maybe there's something to that.
No, I definitely think there is. I think,
Code is hard.
yeah, I don't want to be looking line by line, but like, I don't want to be too far removed from what's in the code. Because, like, you want to see the max size for a block file? I could try and get it from memory. I could try and guess. We could look it up on Google, or we could look at the code. You can see the file. You can see the line. You can go on your own, like, phone, laptop, and see it for yourself. And if you want, remember, like, didn't like Fractal Encrypt make a PR to Bitcoin?
About what?
I don't know. It was a small like PR a while back. I remember you pointed it out.
Oh, did I?
Yeah, in like the list, and yeah. Anyway, it's like anyone the person's an influencer. It's like anyone could make a change to Bitcoin.
Right.
Sometimes a small documentation change, which I think it was.
Right.
But let's say you wanted to make your block files bigger. The back size. You say I want to be a gigabyte long. Knowing where it is means you could go and make the change and start making a PR.
But for Core to actually merge it, there needs to be.
Yeah, they probably won't agree. They're like, gigabyte,
It can't just be some peanut gallery PR. It needs to be something that has an overwhelming.
Yeah, if you think it's important. I mean, some of them, most topics you're not even gonna like realize are being discussed in the GitHub repo. So there's some people. It's like usually what becomes controversial are like what the influencers who know how to use GitHub can like see and bring up to the community.
That's how the cross from the contributor mindshare to the marketing mindshare is. Yeah.
Well, to the users, which is like a weird form of consensus. I mean, the ultimate consensus is just seeing what the changelog is within the repo and choosing whether to upgrade your node or not. I was thinking like. The thing on Twitter, I wanted to bring more things like that up. But if there's anything that you guys ever see and like have a question about in Bitcoin, maybe I'll like have a Google Drive document or something. Yeah, where people can just put their questions in and like I get to spend time like delving into the questions. Whether it's something like aliens. Can aliens make an alternate chain? Maybe we could explore more of that topic and what we could do to try and prevent that. And using like what's actually in the source code today, how easy it would be to adapt, what we could adapt. If it was something smaller, it's like my sometimes I don't see the transactions that I make in my wallet. What's up with that? And most of the time it's like the wallet software specifically, but maybe that's interesting to explore as well.
How many more understandings before we could start talking about covenants?
I mean, we could start talking about.
But do you think there's like pieces to kind of like cover before? Because that's kind of like one of the conversations going on now, right? So
Uh-huh.
to take it from understanding Bitcoin 1, where we looked at Satoshi's initial code base and kind of like the growth of it, and to these last couple ones where we took a smaller topic, like, do you think that there's more topics that you think are worth someone who keeps coming back? So I've come to most of them, all of them, and I think to put together like the bigger picture on covenants, is there anything that is a prerequisite for understanding that discussion?
There's like, so remember I went over the interpreter and script.
Yeah.
That was like the first one, but
Yeah.
you know,
Script was 2, right?
uh,
Or was script 1?
no, I think it was 1. Yeah, 1, and
Are
then
these talks like saved?
I saved this one. Last time I messed up.
The
So
slides are, but the recording.
yeah, the slides are the recordings. I have some of them on my computer, or like all the ones except for the last one for you. Not the first one either.
So this one and the
This one, a part of last one,
before last
and then the whole second one.
So 2 of them.
Yeah, so yeah, this is the fourth one. So I have this one, a part of the third one, but like I say a part because
We
More than half.
noticed that
Yeah.
during recording.
well the mic wasn't working.
the mic
yeah.
wasn't recording audio.
Well, no one's watching to tell me. Yeah,
But maybe-
and the second
maybe-
one I fully
Yeah, we
recorded.
could do script again as a lead-in, and then
Mhm.
like kind of have
That'd
the
be cool.
covenants one.
Yeah,
Like as a follow-up. So like, or maybe I don't know. I'm just thinking of.
It's kind of cool. Yeah, like you kind of have this goal, and it's like the lead up to
Right,
covenants.
right. Like
Yeah.
which topic? I don't know. I
Like
don't
each week,
understand it. But
each
that's
week
why
could
I'm
be its own
thinking,
independent
like,
thing, but it could be leading up to like
Yeah.
if you attend these 4, then the 5th one is like kind of the culmination.
Yeah.
well, yeah, I'm thinking like if I do enough of these, you know, and
Yeah.
still get attendees, of course. Like you start to understand more of like Bitcoin in a
Right.
holistic sense, and like hopefully I can touch at least upon every component. Kind of like church. Let's say when you go to church, but you end up reading the whole Bible, yeah, after a certain amount of time. That's what they say. So you
Right.
go long enough, you cover every part of the Bible, kind
Yeah.
of.
Right, but most of them will kind of reference back Psalms, like
Right,
like,
yeah.
There's this like book that keeps getting referenced. So like if you don't cover like a lot of that,
Yeah,
like,
well,
the
yeah.
rest of the New Testament is always referencing back to the Old Testament.
Well, yeah, the Bible's not quite. You know, you
But
could
we
definitely
have-
read the New Testament
We
without
have
the Old
modern
Testament.
Bitcoin code base, and then we have like original Bitcoin
Right.
code base. So we have a little bit of a an analogy.
Yeah. Plus, you have other implementations,
Yeah.
but like consensus-wise.
Yeah, can we look
yeah,
at knots? Can we do one that is just knots as a
Yeah,
topic?
I'd have to find all the differences.
Yeah, that would be a
but
fun
we
topic,
could
okay.
for sure look at knots, why certain differences
yeah.
are made. I'm not like opposed to even some of the policies that he sets.
Yeah.
So-
Cool. No, I think understanding like somebody who is contributing to core and also running their own node software.
Yeah.
Like why are they like what choices and where are the disagreements? I
Mhm.
feel like that's some of the interesting stuff that I currently don't understand that I would like to.
Yeah, so
And should women be able to vote?
Yeah, I'm not sure about that.
I'll let you be the guest lecturer for that presentation.
Okay. Cool.
But yeah, so I'll make the document. Yeah, the thing about interpreter and scripts, the first one was I had a attendee. I'll make his pseudonym D-Dog.
D-Dog.
Yeah, he was saying that like remember I had too much information in. He was like I could have just had it for script and not
Right.
done interpreter stuff, just like very basic things like how you add two numbers, you know. So like I have to find a happy medium of like how much I want to go into. Like I could have also broken down this presentation into like simpler things and just covered less.
I think with consistent iteration, you'll have it packaged in a way that like is going to hit for a certain audience. But like if
Yeah.
you do start getting more people coming in that are technical, are coming from either a CS or some sort of development engineering background, like it's a different conversation. And you probably like hear it, and maybe you are doing more of the code and less of the high level. But I think you gotta speak to your audience, and
Yeah,
this is
I think this is a good ratio. Yeah, I think this is a good ratio. Even with developers come in, going line by line is still kind of like,
Tedious.
you know, yeah, it's something like I don't know. You kind of want to do on your own. It's,
Sure.
yeah, unless like you're doing it for a specific purpose or like trying to find something. But for understanding, maybe it's or maybe you come with your own questions of pieces you don't understand. But yeah, question based is how I want to make it. So yeah, we could do it on covenants next week, and I could do something very simple on script. What you could do with covenants. You know, me and Barack and Tiro, you know, Fuji Money, and this stuff on Liquid. We had a hackathon we did together for the first Bitcoin Plus Plus, where it was supposed to be like a gambling thing.
Yeah, I remember you showing me that.
Yeah, where like the UI was about like picking a dog that you want to race, and like so it's like, oh, pick dog 1, and there's an opcode that allows you to generate like random numbers on the stack. So you define the interval for that. So we did that, and when you execute this transaction, it would try and do the random number, and after it resolved, you would go and claim the money if you were the winner. But we use covenants to kind of orchestrate all that.
The CTV implement.
Oh no, we use Liquid covenant. Liquid doesn't
The
use
opcodes.
CTV.
Okay.
Yeah, it uses check sig from stack is like the one,
CSS.
the base one, yeah, from covenants. And with check sig from stack, you could do a lot of things, like you could constrain how much Bitcoin leaves on the output for UTXO, like that you want to spend. So like I could say this UTXO, if it's spent, I only want 1 Bitcoin. Let's say it's 2 Bitcoin, this UTXO. I'll say I only want 1 Bitcoin to be spent in output 1, and I want the other Bitcoin to be distributed 0.5 on output 2 and 0.5 on output 3. You could do things like that with covenants.
So you would, if that was a topic, you would be largely focused on Liquid to show off some of the stuff? Or is that,
Yeah, I think that would be an
this
interesting
could
thing.
potentially end up in Bitcoin Core, but for now, to see it actually run and how it's implemented.
Yeah,
how
you could
works.
see it today.
Yeah.
Yeah, in Liquid with check sig from stack. Yeah, transaction hash is not in Liquid.
TXS.
And then, yeah, the other thing, check CTV is not in. So Liquid has its own set of opcodes, and no one's really pushing for a lot of those, except for check sig from stack, which is like the oldest that it's been in Liquid, like oldest opcode.
And then the SIG
for
hash,
covenants.
any prev out as a way to construct these, is that like a different topic? Would that be it's completely separate?
Yeah, I think it's like
Yeah.
the reasons that they were made and like
Yeah.
the benefits is separate.
Okay.
In fact, I think that would be a great topic for like lit devs.
Yeah, yeah. I
Or
know.
like, yeah.
Big D is on APF.
Yeah. D dog. Right. If he has a big D, yeah, you can call big D too. You know.
D-dog, that's better.
Oh yeah.
Big D.
All right. I'll end the stream there. Thanks.
End it on Big D. Cheers.
Yeah. Whoever's attending, I don't know. It might just be you on this computer. I don't know the viewers. But yeah.
No,
All
it's
right.
not. Someone else.
Okay. Well, thanks for tuning in. Someone else. And bye.